We see your presenter view.
Okay, it's the other way around, but it's okay. So I think that will do for now. So I will speak about our project, which is an Erasmus project. Erasmus is the main European framework for educational projects. It lasted 3 years, and unfortunately it's about to end of December. It was a good 3 years. We had a lot of fun. The A4BD consortium consisted of the University of Patras, which I represent. I'm a PhD student there. We also had the University High School participating, the Lepaya Society of the Blind from Latvia, a blind association, a middle school from Spain, Thei Plahara, a middle school from France in Reunion Island, a special school from Cyprus, and a special school from Poland. So since the main target of the project was educational, we had schools participating and the university was the technical partner in a sense. So this project was inspired by 3 things. One, we wanted to provide inclusion and equal opportunities for everyone. 2, for those of us who love astronomy, I'm an electrical engineer, but astronomy is my passion and hobby. I'm an amateur astronomer. For me, astronomy is not only science, but it's also beauty. And number 3, when it comes to astronomy, we all know that practically we're all blind because we only see a small part of the universe anyway. So our project had 3 work packages. The first one was to build an astronomical objects database that would form the data for the project. The second package was to create the software for oral interpretation of astronomical images, as we called it. And the third package, which we're finishing now, is a remote observation website for the disabled. So the object database, I won't go into much detail, but in a few words, we had to select images that would be representative of all astronomical objects. Simple ones, more complex ones, big ones, small ones, color ones, some with less color, and even from the North Hemisphere and the South Hemisphere. That's why we had the opportunity. One of our partners was from the Reunion Islands, so I had the beautiful opportunity to visit the South Sky for the first time, which was an amazing experience. Here you can see these photos, we're using them for the project. You can see the Magellan galaxies, and you can see the big globular clusters of the South Sky. That was an amazing experience. So the main part of the project was to create the software to interpret those images. To be honest, it wasn't our specialty, so we pretty much started from zero. And what we first did was to survey the actual users that were going to use the software, which is the visually impaired. So with the help of our partners, we made a questionnaire consisting of 15 questions. We wanted to find out some things about their condition, for instance, the degree of the visual impairment, the time they acquired the visual impairment, because it seemed quite important if it was at birth or later in life, some preferences, for instance, if they wanted to find out about astronomy with emphasis on education or on enjoyment, which things they had less understanding of due to their visual impairment, and some other preferences such as real music versus synthesized music, or speech versus music. We had 132 individuals with some degree of visual impairment from 5 different countries that filled in this questionnaire. We have the data. I'm sure we can share it with the partners, which were, because they were the answers were very helpful in helping us understand how to design the software. For instance, we had a lot of people with severe visual impairment, so we have data from blind people that cannot see anything. We have data from people that have their condition as a child, as an adult, and at birth. We found out people prefer education and enjoyment, although enjoyment somewhat more than education. We found out, for example, that they have difficulty not only understanding complex principles related to astronomy, but also basic principles and even how the astronomical objects really are. So there is a lot of things the visually impaired do not understand about the sky up there. In the technical side, we use the MATLAB to do some image preprocessing. Our bases are 2D images in color or not, and we wanted to transfer to the user the feeling of a two-dimensional astrophotograph. So first thing we did technically was to detect the edges and the contours of the objects to find the functions and the variables that would work most of the time in order to detect the edges that have a meaning for the person that watches the images, not the edges that may be more pronounced in the data, but the one that people who can see would spot first. We had to do a quantization of the images because in our demos we found out that we had to reduce the complexity of the images. Having too much resolution was more difficult for people to understand. So we used algorithms to reduce complexity, mainly by replacing each pixel with a bigger square of pixels that have the color of the average color of the pixel they replace. We had to do histograms of the images and detect their brightness levels. For instance, here at the total eclipse in the US in 2017, this image is mine. We can see that most of the histogram is dark, and there are a few light parts, which is the corona. The most difficult part, of course, was the color. How do we detect color? After doing a lot of tests, we were asked by the users that we needed to reduce the different colors that we use to something like the colors of the rainbow, which, even though they cannot see, is something that is known to them. They know what the rainbow is, they know it has colors, but just some of them cannot really grasp the concept of colors. So the closest thing to that was the sonochromatic scale. We did versions with both the pure sonochromatic scale and the larger sonochromatic scale that pretty much gives a note to each of the main colors of the rainbow. And then we had to put that into an application. We decided we wanted to have an Android application because it's the easiest way to do some prototyping. Android devices are everywhere and they're cheap, and you can install software that is not authorized on them. And the main functions of the app should be select an image, detect the speed of the finger, detect the center point of the finger, and generate the sound. So we imagined our user interface something like that, a voice-guided image selection screen would aid the user to select an image. Then we used a vibration to help the user detect the edges and the contour of the object, and then by the user moving the finger around, the user would hear a sound that would represent what's under the finger. So we had a very, 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 I cannot stress it enough, interesting experience of conducting 10 demos in 4 different countries with the blind associations of the cities participating in the project, which was a very revealing experience to us. We had the chance to speak with the visually impaired and listen to their preferences and listen to them telling us what we're doing wrong. So even though at first we did not use vibration, we had the feedback that since we're using a tablet or a touch device, and most of them have vibration, we should definitely use vibration because all of them are very, very keen to haptic feedback. We got some very important feedback about the sound change speed. Our initial versions were very fast, and people would have a hard time understanding sound if it changed too often. So this is what led us to quantizing the image. Also, we had to quantize the number of different sounds that we use. And the sweet spot, according to most of the users, were about 10 different sounds and 10 different levels of volume. So if we used too many sounds or too many different volumes, they had a hard time understanding what was what. Also, we got some feedback about how the sounds should fade in and out, and much, much more. Initially, we started creating the application using the Android framework provided by Google, but that was very limiting for if you wanted to do sound functions. So we switched to the Unity platform, which is the platform mostly used around the world to create games. If you're playing a game in your tablet or phone, there is a high chance that it was created with Unity. And with Unity, you can easily do a lot of multimedia stuff. So this is a screenshot of our latest version. I have here a tablet with me, so I can show you a bit how it works. So from our main screen, as I said, you can complete the training guide here using vibration. When you reach the edge of an object, you get a vibration. Users are trained and they're told this is a triangle, and they're guided into moving their finger around so they can understand how the vibration edge detection works. Then they go through the sound phase so they can switch between two colors and see how two different colors are represented. They can see how a gradient is represented, and of course how the whole of the scale is represented. So this prepares them to actually go and look at an astronomical image. Here on this side, we have images that are stored in the application, and here when you see loading, these are images that download over the internet as an update, which is important for the last part of the project. And for instance, if you look at solar eclipse, you can only hear one tone, and you can see that it's dark inside, and it's higher volume where the corona is, etc. If you have a very complex image, then of course the sound change is more overwhelming, and it takes some more practice to actually grasp it. So as I said, this part is the one that loads over the internet because that gives us the opportunity to actually do the third part of the project, which is that this application is connected to an observatory that we are connecting through the internet. So this is my rooftop observatory in my home that I use occasionally to take photos. And we're using some software on a Raspberry Pi that is open source. It's based on K-stars, and it can actually guide the telescope, and images taken through the software appear on the application automatically. So this was pretty much our application. On Monday and Tuesday, we're having a 2-day conference that also Anita Janella is speaking, and would love it if you can register and join. This is the link that you can register to receive the online link. Also, some last-minute news. I found out that from our group, we had another project funded that has to do with geology for the visually impaired and the disabled, which concerns sonification of UNESCO geoparks. So that hasn't started yet, but I think it will be interesting for the future. Thank you. I will be pasting the link that you can register to our conference in the chat. Thanks for listening.